Fireside Chat. And during today's discussion, what we're gonna have two people to discuss from the past to the future, a panel discussion from AI experts. This is today's topic. And the moderator for this session will be Julian. Julian is also leading a group which is called Machine Learning Together, which I suggest to check it out, where they do more, let's say, hands-on development and different stuff. It's a kind of like similar to Apply AI, but more practical and more for everyone to just jump there and learning new skills. So I welcome to the stage Julian, that will do the introduction. And thanks a lot for coming, and we hope to see you soon.
So thank you, Marco. And as Marco said, we are going to do an interview to these three fantastic data scientists. And I want to start with Claudio Bottari. Claudio Bottari is one of the first data scientists that I meet in Milan when Bottari, sorry.
Let's go.
Bottari, one of the first data scientists that I meet in Milan when I came here. So Claudio Bottari, what I can say? Introduce yourself. What do you do? What did you study in your past? So a little introduction of yourself, if you want.
Well, I'm very old, so there's a lot to do. I will try to summarize. Basically, well, okay. If you look up from me on LinkedIn, you can find that I'm Chief Innovation Officer for Kirey Group, which is a system integrator here based in Milan and other cities like Turin, Padua, Florence. And well, I'm also head of artificial intelligence development for the group. So, which is basically my job. I started doing innovation because it was a topic that, well, actually, that I like a lot. But I come from machine learning. I came from machine learning. But before that, I used to be a software developer. Software architect and so on. I mean, I started back in '99, professionally speaking, so it was a long time ago. A very long time ago. I started programming when I was 14. That's the point. I mean, it was like the early.
Really, you're very young.
Yes, exactly.
you were.
I was very young. Yeah.
Yes.
I had a PC. I wanted a personal computer because I was a crazy teenager, I guess. And then I started with a friend. We started programming by ourselves. We started with Turbo Pascal, then C, C++, and so on. Then I studied something else because I was a crazy teenager. So I studied law, but then, then I like programming. I like PC. That's it. So
yes,
I do this job. It's it. Yeah.
Wow. So you have a long history in this field. So
yes, I've seen a lot. Yeah, exactly. Yeah.
Wow.
Which is a good perspective, I guess. Instead, being so young as you are. Sorry, my camera is messing up. Okay. Yes. I started in '99 with the Millennium Bug came to Milan. Everybody was working with that, so I started working with this database and application, so on. Yeah. And how I came up with machine learning? Well, simply put, I had an idea about machine learning that, I first heard about machine learning, I mean, maybe in late 80s. So we're talking about Express system. And honestly, I didn't get it. I simply didn't get it. I thought it was
really?
Yes, I just didn't get it.
So it's difficult for you too in the end.
Yes, especially because there weren't information at that time. I remember reading on a newspaper and MC microcomputer. There was a chapter about machine learning. I didn't catch anything about it, so it was kind of obscure for me. Then I heard about it from a client that asked me about it. Say, what's machine learning? I say, I don't know, something. I guess it works, but I don't really know. So I started looking up into it. I fell in love. Actually, I fell in love for a particular reason, because what I struggle being a software developer is with clients. Okay, imagine a client asks you for doing something, and because he's supposed to know, but he really doesn't know how perform things, and then and then you have to do it 3 times because he actually doesn't know his job. Okay, and on the other hand, I liked about machine learning the fact that this is data, just data. You can trust them.
Yeah, so
it is what it is. I mean, and you make a model with data and not talking with people that have a bias perspective and so on. So that was the crucial point for me. What triggered me was that. Yeah, then I fell in love, and then in the beginning I didn't understand basically anything. I was completely lost. I mean, there is like 1,000 algorithms. If you look up by yourself, everything looks important. Okay.
Okay. Yeah.
That's what happened to me. You go to YouTube and you heard about stuff about the machine. Okay, from people that do just that, and for them it is the shit. Okay, can I say that? then you talk with somebody that does deep learning, and so that's it. Then statistical analysis, that's it. Random forest, that's it. So it was very complicated in the beginning, and I had the opportunity to learn from a professor that does old school AI, Professor Buscema, and that taught me a lot. And then I do all the usual stuff, Coursera and so on. Then I start to practice, and then at the point I start working. It was nice.
So you have a very big experience so in machine learning in the end. So
I guess it depends.
I know it. I trust you.
It depends.
But so in the end, for the youngest student, what do you think is the best path? So what do you have to study at the beginning? So because I know that you in the before the coronavirus, you are what you really love to do is to do some lecture with Tavernelli in machine learning.
Yes.
So we want to share your knowledge with other students. So what do you think is in general, after this experience, the best way to learn machine learning in general?
There is no one, because everybody is different. That's the whole point. And when I tried to bring in Milan TVML, it was for that reason, because developers know had the right to know as well. Okay, that's the whole point. I came late to the fast AI approach. Okay, the top
remember it?
Approach. Yes, I came very late, and I fell in love for many reasons. First of all, because it was different. Okay, and it was very practical as I am. Okay, and it was focused on the development, on the code. It was for programmers. Instead, all the other how can I say, canonical paths are for data scientists that come from math, from this type of science. So top down instead bottom up. I think it is good to give an alternative. Okay, because otherwise, yes. I mean, you can go to Coursera. You can roll to data science in Bicocca, Statale, great university that has great programs, so on. You can. Yes, that basically. I want to give an alternative, because at this point, with machine learning, I think it is doable for a programmer that really wants to do it, to do great stuff. Okay.
Yeah, quite clear. So I see. I'm seeing that in machine learning we are seeing this fact, this different approach. We are not programming each row of code, but we see an API, I don't know, whatever we want, that do all the stuff. So what is the role now for the future of the data scientist, in your opinion?
I think that the future is that data scientists won't be only a data scientist. Okay, and this is this is a common trait of all the sectors, that nobody does one job. We were talking about the computer programmer before. Yes, the computer programmer doesn't just do code. There's all the do the analysis, for example, and so on. The project management, okay, and who knows what other jobs needs to do for his job. I mean, a computer programmer already knows data, for example, because obviously he accessed the database over his career. So, and I think that the future for data scientists is not just be data scientists, knows more than just the data. Because it's very complex. That's the whole point. Putting in production models is very complex. It's not just about the model and the science behind it. It's about, for example, ML pipeline, DevOps, functional analysis, dealing with clients, and so on. It's a lot of jobs. Okay, so that's it. So I think the future is that, basically that.
So the job is completely, sorry.
Yeah, no, back in the day, to do machine learning, I know because I know a lot of people that used to do AI back in the days. But just when you were able to program a neural network, you are a data scientist. Okay, this is not like that. Actually, at this time, you don't have to. You don't need to do it. There are great frameworks. You can just use that and remain at high level, for example. I mean, it's a different job, can be performed in different ways.
Yeah, so the job is changing since the beginning. So at the beginning, you were a pure programmer or a mathematician, something like that. Now you have to be something different. In the future, this will be completely different. So I think that maybe you have to be a computer scientist, okay, but and you have to know the basics, but maybe you will need this, more skills, more related, as you said, with I don't know, the how to develop, how to put in production. So it's or for example, to know some particular fields. I saw something related with that, to know a particular field and how to apply data science to this field.
Yes, that would be very important. I mean, if you think about it, there will be a verticals. Okay, there will be more specialization. Not that I think that knows everything, doesn't matter. I mean, there will be data scientist that does just time series, for example.
Yeah, exactly. what I really love. Yeah. So this is very important, in my opinion, because when we talk about machine learning, we usually talk about algorithms, and we think that this is the main point. But in the end, when you do this job, you see that is not the most important point. You have to see some other things. And this is very important to say.
There will be people that are doing just that.
Yes, exactly.
Just doing research, and
yes,
others just will apply. Like it is in the, for example, again, if you want to make a parallel with the computer development world, there was a time when to make a website, you do have to write HTML by hand, or now use framework. Okay.
Yes, exactly.
Again, with JavaScript, now there is everything about JavaScript. Maybe people use it without knowing it, and it will be stuff like that. And it's totally fine. I mean, it's a huge field, and doesn't mean that you have to know everything.
Yes, quite interesting. And now I want to ask you a thing that I'm very curious of. So you are a chief innovation officer, but what is it in reality? What do you usually do?
I do a bunch of stuff. I mean, really a bunch of stuff. I always said it is a buzzword. It's like nothing. No, obviously, I work for a company, which is a group, and actually provides a service for clients. What clients do usually wants to do things better in a new way, and we want to innovate. That's
okay.
How to put it in practical terms is always different, because the client is different, use case is different. And my part of my job is sometimes just to consult about what's the best approach to do something, which is sometimes can require machine learning, sometimes something else. I mean, there are other aspects of this innovation field. I mean, it's like, for example, I promote a lot RPA, which is another way to do practical things.
RPA?
RPA, yeah, robotic process automation. Okay.
Ah, okay.
Or other stuff. I mean, sometimes it's just to consult about the possibility that we have. Okay.
So it's quite huge in general.
Yes, it's a huge field. So when a customer has a need and that doesn't know how to put actually in reality, it costs me. Then we'll see if I can help myself or just call a colleague or some other company. Or just say that it's not doable. Sometimes it's like that. Sometimes you have to be very transparent with your clients.
It's very interesting. You're a very interesting data scientist. I want to say,
because I'm not a data scientist. That's
exactly. You're something more in general. You do a lot of stuff.
Well, yeah, yes, because I'm old. That's the point.
Yeah, and so if you're old, you have a lot of experience. So I want to ask you, what are the biggest mistakes that you have done during your work, during your career in general?
There are many. I mean, really too many. Really too many. And I don't even blame myself. I mean, you make the best you can do with the tools that you have in hand in that time, and then you find out what is missing, and maybe you grab some new tools.
Okay. But
what I'm trying to say is that sometimes you have to try and not reach your goal to understand what you really need. That's the point of innovation. Okay, something that I really like. If you succeed every time you try to innovate, it means that you are not doing innovation. Okay.
Yes, clear.
It means that you are playing safe.
You
go to in the unknown that you're doing innovation and you challenge yourself. Sometimes it works, sometimes it doesn't. It is important to assess what you've done and what you've done wrong, so you can try it again, maybe, if you have the possibility. Sometimes you don't. Sometimes you don't. I always, for example, say that. Okay, why I say that doing regression is bad. It's a bad attitude, because I know, because the classification works well. Why I know it? Because I tried many times to do a regression that works and never does like I would like to. Okay.
Yeah.
Why I don't like time series? Because time series are very tricky.
Yes, I agree with you. Absolutely.
Exactly. That's it. And why I know it? Because I tried many times, I didn't succeed. Okay.
So you have just a little experience about time series, or you worked a lot with them? Because as you know, I really love them. So I am very interested.
I used to. Now I avoid them.
Really?
I do. Honestly, I do. Well, sometimes that's what you have to do. It's like,
yeah. Well, so but
I don't like to fail. That's the point. I mean,
you don't want to. So each time you say, okay, I don't want to work with a time series, so I want to change.
Time series are tricky. I mean, and you can tell why, because it is artificial intelligence. So you can measure how difficult it is. Just look at people looking at this data. Think about COVID-19. There is actually people that every time that we have less cases every day say yay, and are the same people tomorrow say, okay, no, now I'm depressed because we have few. It's like time series are tricky. And trick people like tricky machine. That's so
clear. So and usually, what do you analyze? I don't know. What do you prefer?
Okay, I would like to do NLP, honestly, but
it's difficult, or it's not possible.
I always get structured data, something like that.
Okay.
I would love to.
Because I remember that you really love computer vision, but
I never do computer vision. Okay.
Really? Why?
Because working with company, usually you treat structured data. That's
okay.
what people that's what company have.
yeah, clear, yeah.
Basically, and not only for that reason. Sometimes you just want to reason in terms of the minimum viable product, and I know by experience that usually you get more result with structured data. Because it's easier. That's it.
So okay, so we will see the same thing with Paolo Galeone. That is, I think he works a lot with computer vision. So we will see it later. If we have the same answer.
I know Paolo work is great.
No, okay. So now I think that we can ask to the public if we have some questions to Claudio, because it's a very interactive interview. So I want to ask to the people if we have some questions.
Everybody's shy today.
Yes,
I have a question.
Hello, Giovanna.
Hey. Hi, everyone. Hi, Claudio. Congratulations for your career. It's a very nice career, and it's very inspiring to hear all the things that you are doing. So thank you.
I'm just old, Giovanna.
I would like to know what is your favorite project that you have developed so far.
Okay. Well, there are many. Sometimes it's just where I like to see. I like when you can see machine learning where there isn't. Okay. That there is a project I've done internally. It is for measuring people opinion of themselves and the others, and yes, that's basically it. And I use PageRank and the custom algorithm to understand that. Basically, we ask to our colleague to evaluate themselves, okay, and others, and then there is an algorithm that fills the blank, okay. And that's funny because because I came up with the idea, say, let's use an algorithm, okay? Just don't do the average, because it doesn't work. You don't have enough data. Okay. That's it.
So you talked about PageRank. So you worked with graph data science, for example.
I would love to.
Okay.
I would love to. Yes, sometimes I kind of work with graph data science. Yes.
So what do you think about?
I'm not a great expert. I think it's a great field. Okay, again, I think it's great. Okay, maybe Paolo does something like that. Okay. Do you remember? Did I remember correctly? No, it wasn't you. Okay. Anyway, no, I think it's very interesting. Very interesting. The world that we live in is made like that. Okay. I think it's an interest field, and I would like to see more easy approach to quickest go to a result. I mean, I would like to try, for example, TensorFlow graph, but I didn't get the opportunity yet. That's basically yeah. And I work some projects that are kind of graph related, but nothing major. I would say nothing major.
Yes, this is one of the field that I was studying, and I think it's quite interesting. So this is the reason of my question.
Yes, but it has another level of complication, so something that is already very, very complicated. So what I notice is that is harder to get practical. That's it.
Yeah.
I don't want to do.
Yeah. So do we have some?
But I don't know, Giovanni, if I answered to your question. Okay. What I basically think is that machine learning can be used it will be used in a lot of fields, some that we didn't think about yet. Okay. So, for example, I like recommendation systems. Okay. And in not just for recommend product and movies on Netflix. So. Yes.
Do you think that this is useful in general? I don't know, for companies.
Yes, definitely it is. Definitely it is. It's not
yes,
used as
example?
much. Okay.
For example, can you say in a field where you can use them?
Well, it is already used. I mean, think about think about advertisement, for example. Think about a company insurance that has to give you something custom for you. Okay.
Okay.
It can be used in that way. Okay.
Wow. Yes. Yeah. So
it can be used to, for example, to customize a product to your need. Okay. That's something. Usually, what we think about is that let's choose a product based on what a recommendation system is telling you. What to me it can be interesting is that not just take it out of shelf, okay, but customize it for you. And if you think about it, it can be used on anything, like just basically anything that we see, because everything that we do, especially online, for example, is kind of that way. Try to be customized in that way.
Yeah.
It is used in this way. Think about the Facebook feed, for example, which is a huge recommendation system. But
I will see it tomorrow. These kind of algorithms, because I really don't know them, so I have to see something about. But if you say that they are interesting, it's
yes, yes, it's huge. It's huge.
Okay.
Not just Facebook. There is the other company. Well, let me tell you later, because now it's very late.
Okay.
They just do the recommendation system.
Quite interesting.
Yes.
So, do we have other questions from the public?
I have a question for Claudio. So, you work in innovation. So, what is the most innovative project that you did in the last year?
Let me think about it. I don't know if I can talk about it, but we work basically with insurance and banks, okay? And we work with debt positions a lot, okay? And we try to, okay, with machine learning, we use that from side and debt collectors on the other, and we kind of made a match, like it was a dating app, okay? So that's something that I'm very proud about last year job. It's like, again, think about a dating app, but for debts and debts collector. Okay, so
which algorithms you used in the background, if you can disclose?
We use basically neural networks. Okay, basically neural networks. We do forecast and then create a custom algorithm that aggregates the data. It makes a smart distribution based on forecasting. Basically, neural networks.
Yes, interesting, as usual.
Did I answer or tell you more? We can talk about it. just very long.
So, other questions? Okay, I think so. Now we can finish with you, Claudio. It was a very interesting.
I may ask a question to Claudio.
Sure. Okay.
How big is your team?
Okay.
How many people?
We have 5 at the moment. Okay. I would say that okay, when you work in a group, which is a kind of a big size, the team are kind of elastic because it depends on the project you have to do. So we have a fixed team as innovation, and then we have resources that are allocated in other business line, and plus we have the nearshore. So our team is 5, but then if is required, we have we can grow pretty quick.
And what about the roles of these people? They are all developers, or do you have a
no. Our except me, we have 2 data scientists and 2 machine learning engineers. Okay, we work a lot with with the engineering part, and we try to collaborate with our DevOps team, because in perspective, what I can see in the field, if I could say so, is that MLOps will be huge in our sector, and I like to prepare for that. So that's basically our vision. From one part, MLOps, from the other, I'm trying to push in Italy an American company that distributes pre-engineered models, okay, related to use case. What I find out over the last years is that very hard to get engagement for a client for a machine learning initiative, okay, and I'm trying to bring this model in which we're not talking about science with the clients, we're talking about use cases, something that we can relate to. Okay. How we do so? We have a partnership with an American company that is doing machine learning from the past 17 years, and they collected a bunch of use cases and references and models, and they now offer this off the shelf. Okay, so basically we don't start from scratch, we start from something that already has been done, and so we have already feature selection, model, and the metrics. That's great, and I hope I answered to your question.
Yes, and just one other question. How do you rate in your clients, in your relation with your clients, the explainability of a model? Because I think that customers need to be sure that the model you have developed so far is really what they care for.
Yes, exactly. And it is very, very tricky. Okay. Sometimes you find a customer that is, sometimes the customer that found it is very concerned about explainability. It doesn't even take an initiative of this type. Okay. Because maybe can relate better to other type of models. And think about back in insurance, for example, when you have to formalize their process, sometimes they cannot relate it to when make decisions. I mean, they cannot use a machine learning model because they are not able to explain it in a document. On the other hand, there are people that are not interested at all about this. They just want to have a model that works and that brings money. So they are the other perspective, and maybe this one is the one that is more willing to risk more. So say, okay, it's a black box, I don't care. I tried personally to push for explainability. For example, the use case I was saying before, in that particular case, we provide a extensive report about the choices that were made. Okay, so basically, we make an assignment or a depth position to a collector. We explain precisely why that decision was made, and I can tell about it if you want. In that case, we push that a lot. But honestly, I don't know if the message was so required by the customer. Maybe it was the same if I didn't do it. Did they answer, Paolo? Sorry.
Oh, yeah, yes. Okay. Yes, I've been working for a company in the insurance field, so I know what you.
So they are concerned about it. Okay.
Yes. And I've been lucky because I can do some experiment with the NLP, and so lucky me.
Well, that's good. Lucky you, exactly. I love NLP, honestly.
So thank you, Claudio, for your answers, and thank you for your time in particular. So I can say that now we can say goodbye to Claudio and pass to the other data scientists. So Bye bye, Claudio. Thank you for really thank you for your time. Bye bye, and have a nice evening. So now we can continue with Paolo and Ilaria, and what I want to do is to do something different. For example, if we reach to I don't know, to ask the same questions to the two data scientists and try to see the different approach, different answers. So now we will start with a little presentation about Paolo and Ilaria, and after we can do whatever we want. So we can start with Ilaria. So Ilaria, hello Ilaria, thank you to join us. Can you explain a little bit about yourself? What did you do in your past? What do you usually do? So explain a little bit about yourself.
For sure. Hello everybody, and thanks Julian for inviting me in this meeting. I'm Ilaria. Nice to meet you all. So I'm a lead data scientist in Data Reply. So this is my role. For those who doesn't know, Data Reply is the reply group company in that mainly works on big data and artificial intelligence. In the last couple of years, we started working also on quantum computing. So we work on data, I would say 360 degrees around the data. As a leading data scientist, what I do is doing data science. As Claudio was saying, doing data science means a lot of stuff. So it doesn't mean just building an algorithm. It doesn't mean just teaching someone else, a junior, how to approach data science. And it doesn't mean just interact with the clients. It means a lot of activities. So I wouldn't say that I have a standard day of work. I have different activities that I usually take care during my day, but just to give you an idea how I reached this point. So I studied mathematical engineering. So I'm from the mathematical background. Of course, the university didn't give all the tools and all the knowledge that you need to really start doing data science. For sure is a baseline. But then what I realized in the last 5 years that I worked in this field is that what you can really learn is on the field and in the projects. So from university, you bring some tools and you bring a methodology, but then how you really learn to become a data scientist is doing projects and stay with someone and working with someone that did this work in the past before you. And yeah, after these 5 years, what I started from really developing, taking lead of some small projects, and then what I do now is I try to manage this group of data scientists that we have in our business unit of Data Reply that mainly works on sales and marketing projects, meaning that we basically build data products that are based on machine learning and AI for the sales and marketing department of our clients. And what I usually do now is leading them, trying to help them in interacting with our clients and helping them in designing the best technical solution to face the problem that we have every day in the projects. And why not to try to help them in building their career in the data science field, as my mentor did in the past with me. And I'm happy to say that one of my mentors is here connected. So I'm super happy to have it here, Ricardo. And so Ricardo is one of the person that helped me in the very beginning of my career. So thank you to be here. And yeah, this is what I do now. This is what I do now, and yeah, what I usually do during my day.
So I am a mathematical engineer too. So what I want to ask you is, what is, in your opinion, what you learn from this university? For example, what do you think is, from this point of view, better from mathematical engineer with respect to computer science, computer science university? And we will do the same question with Paolo, but on the contrary.
Yeah, of course, there are some positive aspects in the mathematical engineer degree, some negative ones. Of course, the current mathematical engineering degree is a little bit different from the one that I took, because it changed a lot in the last couple of years to really like meet the requirements that a data scientist would need for facing like the everyday problems when starting this work. But yeah, for sure, what I really appreciate of that university is the methodology and the way they want us to react in front of the stress, in front of a new problem, in front of you know, a not easy problem to solve. This is indeed what I really learned most during my university. Of course, I got the basis of machine learning, of programming, and all that kind of stuff, but I don't really believe that part is the most valuable one, because that part can be also learned by yourself. You can, as Claudio was saying, there are a lot of courses in Coursera or online, or, I mean, it's something that you can learn by yourself to really understand how an algorithm works. As long as you have the basics of mathematics and programming, you can build your own skill sets with like a couple of tools that are available now. What is really difficult for me as a data scientist is how to approach a new problem. So something that you haven't seen in the past, something that you don't even know how to solve it. And maybe you don't even know the algorithm that can work that for that problem. But you need a methodology to reach a solution, because we are a consultant. We cannot say, I don't know how to do that. So you have to find a way to find a solution that a priori can work without like, you know, setting up the expectation too high. But on the other hand, to really understand how to bring that problem into a mathematical problem and to get a solution for that. So this like design approach is what I think I really brought directly from the university.
Yes.
Even
so
if
sorry.
No, what I was saying, even if when I ended the university, I said, I don't see that I've done a lot of practical things. So for example, when I went to the Erasmus program in Oslo, in Norway, I used to have a project for every exam. So a practical project, not just theory, not just like practical, but an in theory exam that we did in the Politecnico. But in the end, I realized that the way they asked us to do the exam was really helpful for facing the type of issue that I'm facing right now.
Clear. So the mental approach is the most important thing that you learn from mathematical engineering. Yes, I completely agree with you. I think it's the same. But now I want to shift a little bit to Paolo Galeone to see what he thinks about the computer science engineering, computer science university in general, and I also want to know your history, so introduce yourself.
Okay, so thank you. What can I say? I am a computer engineer. I have a master's degree from the computer engineering faculty of the University of Bologna. And yes, this is pretty much my school background. And after that, I spent 1 year doing a research fellowship at the Computer Vision Laboratory in the University of Bologna, so in the Faculty of Engineering. where I worked on a topic like convolutional neural network applied to object localization and classification. And it was a research fellowship of just 1 year where I have to solve an industrial problem. So there was an industry that was financing my my period of research fellowship.
Yeah.
So right now, instead, I have a double role. I work as a tech lead for this company that is mainly based in Modena, and have another base also in Milan. And this company is Zurotech. We are a pretty big company that in Italy have almost now about 50 developers, and we are working on a project that is still not published, so we are still in a long R&D phase, and our goal is to keep the industry of the buildings, so the building industry, and try to attack this industry. What does it mean? It means that in this project we have several different parts. We have an application where the user can design its building. So it can design its own house, it can design a skyscraper, it can design everything. And then we can produce what the user have drawn inside this application. Of course, all the production is made using a lot of industrial automation. So there is a lot of computer vision inside. And I work mainly on that part. So I work on the computer vision side. That is pretty strange because all the computer vision part is not based in Italy, but of course we have all the machines and all the cameras and all the robots in China, Vietnam. And therefore we were working pretty much remotely, but what it really means is that it's just the data. And in practice, and I also have a double role. So other than managing the machine learning team, where we do computer vision for the 90% of our time, I also am the tech lead for the project. And the project is the machine learning part and the development of this BIM software. And this is also pretty strange because we use other technologies like Unreal Engine, and we are also mixing Unreal Engine and the machine learning together. So it's pretty innovative, let's say.
And okay, quite interesting. And what do you think? What is in your opinion, the main reason for studying computer science at the university instead of mathematical engineering? Mathematical engineering, sorry.
Oh, well, computer science or computer engineering, because I studied computer engineering. I guess that honestly, there is no such a big difference because what it really matters is what you are able to create and build. Then the university gives you the fundamental, gives you the basic math, gives you the ability of resist to the stress, doing all the exams and doing all this stuff. But what it really matters is that, okay, they give you the basics, and then it's up to you to build on these foundations. And honestly, I guess there is no such a big difference between studying computer science, computer engineering, mathematical engineering. What it really matters is a good foundation that you have to use to build upon it.
Well, yes, yeah, okay, so interesting. So now what I want to ask you is, okay, Ilaria is currently working on sales and marketing, and Paolo in computer science, in computer vision, sorry. So now I want to ask you, Ilaria, have you seen your application in sales and marketing some computer vision problems, and how do you solve them in this case, or I don't know. So
yeah, so we are pretty much lucky because when working for sales and marketing departments, we have the chance really to work with all type of data, so structured and unstructured. So regarding the computer vision tasks, the main problem we usually face are two. On one side, when we have to work on forecasting, sales forecasting or demand forecasting, we always have the problem of cold start of new products. So whenever we have new products and we don't have a time series and historical data we can refer to, one of the main approaches is to leverage a similar product and use that history as long as the business background allows that. In the past, when we have to choose the most similar product, we were using structured data, the common attributes and feature of a product. Now we can do it more visually and use the visual features of a product directly from the images. So let's say
for example,
we can simply use the picture of the product and compare visually the two products with simply, I don't know, SMEs network, and you can determine if they belong to the same distribution or to the same family of products. Or in general, you can just extrapolate the visual features with like an embedding or with all the the techniques of the computer vision allows you to transform an unstructured data to a structured one and then apply algorithms on top of it. For example, a clustering algorithm or simply a distance algorithm to understand which one is more similar to the other.
Mm-hmm.
In the end, what we are using is to use computer vision to improve the type of information that you wouldn't get from the structured data, and then apply a traditional algorithm like the one for forecasting. And no matter how much complex is that one, the idea is to use the image to infer additional information of a new product. And this is one of the most common problem in sales and marketing. Another one, of course, is related to recommenders or to visual searches. So whenever you have to recommend a product, you can always leverage the similarity that you have with similar products, as long as your problem is to recommend similar items and, for example, not complementary items.
Mm-hmm.
But yeah, this is, of course, another field. Whenever it comes to personalization, you can leverage the images to do that. And yeah, these are the main traditional problems. And then, of course, we have other experiences with images, but are a little bit farther than the sales and marketing field, because in our team we also work on other topics. A quite innovative one that is the space intelligence one, where we use other type of images. I wouldn't call them like traditional images. So we kind of moving from the traditional computer vision field, and we are entering in a new field of study.
Yes, so can you explain this field a little bit? What do you usually do? What are the applications?
Yeah, sure. So it's important to say that it's a research field. It's not yet something really structured and something that we can say we have years of experience in this field. But this is something we are really investigating, because we believe can really help to create new use cases and leverage new data to bring value to our clients. So what we are doing now is we are mainly studying all the space assets that we may use to bring a practical value for our clients. I want to give two easy examples. One is related to agri-insurance field. So we can use satellite data to monitor the status of a greenfield and to assess the quality or the status of this field thanks to the satellite data that is not just an image, but is a spectrum. So you can leverage more information than the usual RGB images. And so you can like build more complex index out of this type of data to monitor and assess the quality and how this field is transforming day over day due to the weather condition, due to the pollution, due to whatever. And so if we put ourselves as an insurance company, we can say, how can I better react and proactively understand how my field will like change due to all these factors? I use a new type of data to monitor it. Or another example is use satellite data to get information for the movements of people, for traffic, sorry. And in that sense, the additional value is that from a satellite image that is a radar, you can get not just the information of a static point, but also the direction of the movement. And so it's like getting from one point the same type of value that you can get from a video, because you are monitoring the same point over time.
Yeah.
And for example, we have used this type of data for a project that was aiming at predicting the spread of coronavirus. And the idea was to associate the spread of coronavirus with the movement of vehicles in Italy and how to detect the movement of vehicles. So we had a couple of options. Of course, the standard GPS data, but then we tried to leverage also a more innovative type of data that was the satellite one. Of course, as I said, it's a research field. We are still like try to improve this, the techniques that can be used on those data. We are studying along with companies that are working specifically in this field, that have studied for a lot of years this type of data. And we are kind of understanding how to use that, not just for pure research, but to bring this research into a more practical like problem, and how we can really measure the value that this new type of data can bring to our clients.
Yes, quite interesting. So, and when we talk about research, we talk about Paolo as well, because Paolo was a researcher. So I really want to know what you did in your research your life as a researcher, and I want to ask you if you have ever seen the application that Ilaria said, for example, space images and sales and marketing images. So have you ever seen this kind of fields?
So during my research period, no, but when I was just playing around Kaggle and stuff, yes, there were some competition with satellite images, and they were really challenging. And honestly, this is a really fascinating field, and working with satellite images, it's really great. I never had the opportunity to work with this kind of data, but I find it really, really interesting because of all the opportunities that might arise. Endless, I guess. So I never had the opportunity to work on this. But for what about the research? So during the research period, I had to create an application for a company, and this company was, I don't even know if I can say this because there were some kind of NDA, but anyway, in practice, so taking it really, really general, the application was for guiding a robot. So it's there is a camera that looks upon a conveyor, and in this conveyor there might be objects, but not standard objects that you can detect doing a typical pattern matching with traditional computer vision, but there were difficult to find objects because they were deformable with reflections and with all this kind of stuff. And so the goal of the application was to just develop an architecture that is able to overcome all these issues. And the problem is that this was about the 2015, and this was the first year that TensorFlow came out, luckily. So we developed the application using TensorFlow when it was still version 0 point something.
Wow.
Yeah. And then another cool part is that in the actual, so in Zurotech right now, we are still doing some kind of research. For instance, during the last 2 years, we published, I guess, 3 papers. So one of these was a survey about how we can use generative models for doing anomaly detection. So because, of course, we do anomaly detection for the factory data. So we have cameras that just inspect the objects. So this part of the walls of all the product that the factory is creating. And we have to do quality control over them. Of course, when you do anomaly detection, you don't know the defect in advance. So you have to find a way to find what is normal and what is outside of the normal. And it is not an outlier too. So we studied with the team what were the common way to face this kind of problem. And since we were already playing around with the generative models, because during architecture to also trying to tackle the anomaly detection problem. And we studied the most common architecture at the time, and we published this survey. And we work on, or even in this field. And this is really nice because we have the opportunity to study while we develop the application and also doing some kind of publication while we work. So this is something that I'm really proud of the current role.
Wow, it's very interesting. So in general, what do you think is what is the difference between research in a university and research in a company?
Well, it depends on the company, honestly.
Okay.
Because if I have to tell the truth, the difference between doing research at the university and research at the current company is that the research at the university, we have few resources. That's all.
Okay.
And instead, at the company, hey, we need a new pair of GPUs to train this model in parallel. Okay, no problem. Instead, at university, you have to do, okay, we have to ask data, we have to wait 2 months, and then, okay.
Yeah, it's quite difficult. Okay. Yeah. Okay, so I want to ask you some other question about ethics, because in these last days, we are seeing that the European Union is doing some laws related to ethics. So I want to talk about a little bit about this this part. So Paolo, we are seeing in these last weeks some that we have some new apps related with deep fake videos and something like that. What do you think about that? Do you think that is a problem for example for the news to have these new apps that all the people can use, or what do you think about this topic in general?
Honestly, I am terrified by the negative sides of this technology, because it's easy to see that there are a lot of people that have struggles in even understanding the content of an article. And so just imagine that you can throw at these people even the face and the voice of a politician that is saying something completely fake. And then they trust.
Yeah.
And it's really I'm scared about this kind of social behavior that might happen when this technology is applied in the wrong way. And I guess that something like a European Union level regulatory like the GDPR or something similar, so with the same impact, should be done, because it's too easy. Nowadays, it's really too easy. I can create in a couple of hours a video of, I don't know, you, that I'm saying the most terrible things ever, and then you have to prove that you were not you.
Do you think that there is some algorithms to solve this problem? I don't know, something to detect that this video is fake?
Oh, yes, there are, even, but they can be fooled. So even there was an article of some day ago that, for example, I don't remember exactly, maybe Microsoft. So there was an algorithm for the face detection that it's inside the Azure ML toolkit, if I remember correctly. Okay. And they claimed that they won't be able to detect faces that were generated, but after an update, they are now able even to detect faces they are generated, because they have made their model robust to this kind of generation. So this is an example to say that, yes, there is the algorithm, there is another algorithm that can be trained to fool the algorithm. So I guess that it's pretty difficult to create this kind of algorithm, because honestly, it's really complex. It is really, really complex, because just think about the progress that the generative models like GANs have made. So from a 32 by 32 blurry image to a full resolution with almost no defects of a face.
Yeah, I agree with you, really. And another problem that we are seeing is that with this emerging artificial intelligence, the different type of jobs are changing. And so I want to ask to Ilaria, what is a solution for, because we are reducing in some sense the old jobs, and we are moving to other jobs, but we are seeing that the different governments are, for example, the Italian governments are not spending too much monies, too much, we are not doing some investments to give the opportunities to the students in, I don't know, their schools and something like that, to study, I don't know, programming, data science, and also in the universities, we don't see this changing path. So Amazon, for example, provide a solution giving some learning career. For example, you can study when you are in Amazon, and you can change your job, moving to, for example, I don't know, computer science, something like that. But this is not possible it's not possible to change all the society with Amazon. So it's very important that the government do something like that. And Ilaria, what do you think it can? What do you think we can do if we are the government to change and to help this transition for the future?
Well, I'm a little bit against this position, honestly.
Okay.
So I'm still in the position where I'm not sure should be the government doing something like that, because it's not yet, I mean, at least in Italy, I'm talking about Italy. At least in Italy is not yet substituting current jobs with machines or with AI. Is not yet something that is like accommodated by the government, but is more something that is pushed by the companies. because we are still a little bit far from having AI as a commodity, but we are still in the position where AI is really something that is driven by the unique company, not more about the environment. If we were talking about UK or US, then I would be more into that conversation. But in Italy, I believe that the responsibility for that is really about a company. The company is changing the way a job used to be done, because it's substituting it with a machine. Then the company is responsible for allocating the same person to a more valuable type of job. We cannot say that machine can do everything. So if the commitment is to help machining, optimizing internal processing and reducing manual work, usually is time-consuming work, and is usually something that is not really elevating the person that is doing that work. So the really responsibility of the company is to take that part of work and transforming it to something else. I have a fun example that's when I read your question really stick to me, and I was kind of, I don't know if you ever seen Charlie and the Chocolate Factory, the film. No. Yeah, but the most recent one, the one with Johnny Depp.
Yes.
Okay.
Okay, I got it.
There is a funny subplot inside the main plot that is Charlie's daddy was working for a toothpaste factory, and he was screwing the caps on top of the tubes, and he was substituted by a machine. And at the beginning of the film, and at the end of the film, he was hired back to fix the machine that was broken. So the machine that was screwing the caps on top of the tubes was broken. So they hired him back to learn substituting them, to learn fixing the machine. Yeah. So this is a fun example to say is really responsibility of the company. Whenever we are changing the way of working, probably we are creating new jobs, and the very responsibility is to moving from the old work to the new one. And for my experience, and I'm interacting with a lot of clients in the Italian market, and for my experience, they are moving to that direction. So they are already moving to trying to reallocate employees from older and less valuable job to something more relevant and to something that can help the machine in working better, because we cannot forget that we have human in the loop. So we cannot forget that a machine has no matter how much small is that, a machine has an error, an intrinsic error in what it does. So the idea is to try to leverage the most from the two entities, the human and the machine, not really substitute the human with the machine and forget that there is a value that the human can bring in that. At least this is my position for what I'm really seeing in the Italian market. I'm not super expert of what is happening in other companies in Europe or in US, but this is for sure the good sign that I see from the companies here, even if there is no push from the government to do that. But there is no even push from the government or really heavy push from the government in moving into a data-driven company, someone that is using AI. Yeah, we have funds for that, but not such relevant to say, I'm spending X money to really rebuild my internal processes. To experiment, yes, but not to change the way of working inside the company.
Yeah, it's a very positive message in the end. So thank you, Ilaria, for this position.